the modular QoS CLI building blocks. Have you ever been to a mall and been to one of those places in the mall that has the posters that have, the strange jumbled things? I don't know, it's kind of like printed graphics, and you stare at the poster long enough and this 3D image pops out at you? Well, I was doing that for a while, and this was years ago. I was staring at one of these posters, and I hadn't seen one yet. And I sat there and stared, and finally somebody came up and said, "Well, you gotta look at the reflection." And sure enough, I looked at the reflection, and after I blurred my eyes enough, went cross-eyed, I saw this dragon popping out of me, this 3D dragon. I thought, brilliant! This is the most amazing thing I've seen. That's the same effect that you're going to get when you see this new Cisco MQC standard. It's going to be one of those things that you're going to say, wow, how, I'm looking at all these pieces, how do they come together? And all of a sudden it's going to be like, brilliant! It all clicks together, and you're going to see how Cisco's new standard for deploying of quality of service is going to shape how routers work in the coming years. So I'd like to take you on that journey. First off, understanding Cisco's, and I put in parentheses, new MQC standard. It's not new as in it just came out last week, but it is fairly new as standards go. Then we'll go through each piece of the MQC, which, as you see here from this little diagram, it is a hierarchical standard. We're going to start from the bottom, configuring class maps, move up to policy maps, and then apply the service policy. As I like to do whenever I talk about Cisco, I'm going to keep most of this nugget focused in the live interface, because that's what we're going to have to do when we're sitting in front of our Cisco routers, is set this quality of service standard up. Well, let's not waste any time. Let's get right into quality of service using Cisco's MQC standard. If you saw the opening nugget of this entire series, the introduction to QoS, I laid out a little timeline of where QoS has come from in terms of configuration. Cisco started off by using the command line interface to set up all their QoS standards, which meant that you would go on a per interface basis. Say this interface was serial 0. I would jump into interface configuration mode and set up all of my quality of service configuration under that interface. Then I would come over here to say this is Ethernet 0 and do the same thing. Apply all the commands to set up QoS configuration for that interface. It was an interface by interface setup. That was tough not only on you as the administrator configuration-wise, but also on the router processor-wise, because every single interface that it received or sent packets on, it had to reprocess all of those QoS configurations. That's where the MQC comes in. The first thing is it's a lot easier for you to configure, because instead of doing per interface commands that are typically the same between interfaces, you'd most of the time cut and paste, you set up somewhat of templates of quality of service using these class maps and policy maps. Once you do that, you can apply those policy maps to whatever interfaces you want to. It's easier on the routers because all it has to do is refer to the template rather than all the commands on the interface by interface basis. These templates can be cached and remembered for each interface, especially if you're reusing the same template again and again. So here's the 3 levels of quality of service. The first thing that we do is we create a class map. This is where we can classify our traffic. And classifying, again, is just separating our traffic into its different groups. The policy map is where we do things to the traffic. We say, okay, now that you're all standing in the group, for instance, let's say class map 1 matches all HTTP traffic and classifies it in its own little group. Well, we can apply a policy map at that point that says, I want to, for instance, mark all HTTP traffic using this sort of marking so it can be easily identified in the future. Or maybe this policy map says, well, I want to limit HTTP traffic to 100 kilobits per second. Now, I do want to make a note early on in this nugget that while we go through this, I'm going to be talking about a lot of methods and strategies and configurations that we can use to really control our traffic using quality of service. It's not those methods I want to focus on in here. So if I'm seeming a little vague by saying limit to 100 kilobits per second, I am, because this is actually a technology known as policing, which we're going to have a whole nugget on later on. The main thing I want to focus on here is just the structure of MQC and how it's configured. After we have our policy maps created, we can then apply them to the interface. I'll put a big 3 right here. Apply them to the interface in an incoming or outgoing fashion. You can have one policy map per interface per direction. So that means if we're talking about interface E0, I can have one policy map for all incoming traffic. That arrow is in the wrong direction. How about this way? Incoming traffic. And then I can have one policy map for outgoing traffic from that interface. Serial 0, same thing. I can have one policy map for incoming traffic. Let's see if I can get this arrow correct. There we go. Incoming traffic. And then we have a policy for outgoing traffic. So you can see that this incoming and outgoing thing can get pretty confusing as to what direction that's talking about. The way that I remember it is just imagine yourself as the router. You are a router. If you're talking about your serial 0, imagine your right arm. Go ahead and lift up your right arm right now. Hold it in the air. That is your serial 0 interface. If we're talking about incoming traffic, you're talking about traffic coming up your arm and hitting your body because you are the router. If you're talking about outgoing traffic, you're talking about traffic going out of your body and out your right arm. So that's how I always think of these, incoming and outgoing. Think of the interfaces as incoming and outgoing to you as the router. It's always from your perspective. The structure of MQC can never be demonstrated easier than on a live router and how these pieces fit together. So I'd like to take you right there. Configuration using the MQC. What I have right here is a router. It is a production router that we're going to be working on, so there's live traffic running through it. I have one incoming interface, Fast Ethernet 0, and I have one outgoing interface, Serial 0. I'm going to go ahead and pull up the router prompt right on the screen, and I want to show you something right now. I'm going to type in a command that I have named traffic, and you're going to love this command. I'm going to hit enter, and immediately I see all of the different traffic that's currently going through this router. Now if you're looking at that going, that is the coolest command I have ever seen in my life. Don't worry, I'm going to show you where this command comes from and how it works, but that's going to be in the classification and marking nuggets. For now, just accept that we have on this router serial 0, which is the T1 internet connection, and we have input traffic, live traffic coming into, people are downloading right now, HTTP, secure HTTP, POP3, we've got some email traffic, DNS traffic, and we have some SIP, somebody's doing some voice over IP. We also have down here some output traffic. We have traffic that's leaving our router. Remember, you are the router. This serial 0 is just an arm. So it's going away from you, out of your arm, on this output interface of HTTP. Now I'm looking at this and I'm going, wow, I have a bunch of HTTP traffic here. I want to deploy some quality of service to maybe limit that down so that I don't have so much web traffic eating up my T1 bandwidth. Well, here's how it's going to work. The first step in deploying MQC is creating a class map. Creating a class map works like this. From global configuration mode, just like the name applies, you type in class-map, and I'll use the context-sensitive help the whole way through. The class map, from there we can go ahead and type in a word, which is the name of the class map. And a lot of people, just on instinct, will do that. They'll think, oh, well, I just need to name it, so I'll call this web traffic. Enter. And now they're in class map configuration mode. But I want to jump back out and just do a show class map so that you can see right here I have this class map and there's this keyword in between. There's my name, web traffic, but I have this keyword of match all. Under this class map, I'm going to say these are the traffic patterns that I can match. When doing the matching, I can match on a number of criteria. I can say I want to match based on an access list. I want to match based on the size of the packet. I want to match based on who's sending this packet or what website they're going to. So I can have all of these criteria. As a matter of fact, let's get back under there. Get into the class map config mode. I'll type in class map web traffic. And the main command that I use underneath here is this match. I type in match, and then here's all the criteria. I mean, we can use an access list by having this access group. I can match any packets. I can match by using hierarchical class maps. That's pretty crazy. I'll talk about that. I can match using all these different criteria that I have here in this list. The thing is I can match using multiple criteria. For example, let me say I want to match protocol followed by HTTP. Now remember, again, I'm not talking about all the specific criteria, like some of you might be thinking, well, what is that protocol keyword? What are you using to match? Is that an access list? Don't worry, when we talk about classification in the upcoming nuggets, I'll tell you what all these criteria are. For now, I just want to talk about the structure. So let's say I want to match protocol HTTP. Enter. I type that in. Now, I'm going to type in match, and we'll say IP. Well, let's use, thinking an IP address, but let's use this, packet length. So I'm going to say packet length, minimum, we'll say 400 bytes, maximum 600 bytes. Okay. Now I'm going to jump back out, privilege mode, and I'm going to type show class map. I now have this class map which classifies traffic. Remember, that's the whole purpose of this class map. It's not saying what we do with it. It's not limiting it. It's just classifying it. I have class map, match all, web traffic, and right here I have match protocol HTTP. Then I have match packet length min 400, max 600. Since we went into that class map configuration mode and just typed the name web traffic, by default it took a match all criteria. It will always take match all as the default criteria unless you specify it. That means it must match all of these criteria in order to be classified with this class map. That traffic coming in or going out of our router has to be HTTP, and it has to be between 400 and 600 bytes in size. If it doesn't match both of those, this class map does not apply. Now if I typed class map match any web traffic, what that does is transform it to an OR statement. It's saying I will match any traffic that is HTTP, or I will match packets that are between 400 and 600 bytes in length. It doesn't really have to be web traffic. As long as it's a small packet between 400 and 600 bytes, this class map will apply. So a match all statement makes sure that we match all the criteria, and essentially is an AND. Everything must match this and this and this. A match any statement is essentially an OR, saying I must match this or this or this. Those of you programming junkies will quickly latch onto one of those, probably from the and if statements you've had to write before. So that's the first criteria we have to make sure of when we're creating and configuring our class map, is whether we're going to use a match any or match all. After we've done that, we can then start saying what we would like to match. Now, as of right now, I have a few class maps. I have one named test. One is named class default, and let me talk about this one for a moment. By default, every router has a class named class default. What it is it matches any traffic. This is handy when we're starting to deploy our policies and we're saying, well, with web traffic, do this. With FTP traffic, do this. With voice traffic, do that. And then we get to, well, what about everything else that's left over? That's the class default. You can then say, well, for the class default traffic, do this. And that applies to all traffic that you haven't explicitly specified another class for. So let's create a few more class maps so we can get the hang of this. I'm going to create a class map now that is a match any, and I'm going to name this one FTP traffic. And remember, anytime you're creating class maps, you'll always see a match statement. It has to match something. So let's say this one is going to match the protocol FTP. This match protocol is using a feature that Cisco has recently come out with called NBAR, Network-Based Application Recognition. It doesn't need an access list or anything else to recognize FTP on port 21, or on any port for that matter. More on NBAR in that classification world. Let's create one more. Let me get back out, and I'm going to create an access list just so we can use some different criteria. And I'll do access list 5, and we'll go ahead and say this is going to permit anything from We'll put host 172.16.1.9. So we're matching a specific host. Now I can create a class map, and I can say class map, and we'll name it host, which, remember, if I didn't specify, it's going to do a match all. And I'll go ahead and say this is going to match the access group 5. And that essentially says I'm going to classify traffic that comes in from this host. Now remember, again, I have to say this because a lot of people might be saying, well, what's the point? We're now having multiple class maps, all these different IDs. This is just an increment that goes up by 1 each time you create a class map. We have all these class maps, host, test, FTP, web traffic, class default, that are matching all different types of traffic. Are we doing anything yet? The answer is no. All we're doing is classifying traffic into different groups. The doing is the job of the policy map. That's the next thing. So the first thing, I want to make sure we don't jump ahead too far too fast. The first thing you always have to do is create class maps that classifies, or I should say separates, your different traffic patterns into separate groups. Anytime you're going to want to apply a policy to a group of traffic, you'll need to classify that traffic into a group. Essentially, we're moving all those children, all the kindergarten kids, into the different groups, standing in different groups, first graders, second graders, third graders. Next, we'll be saying what we want to do to each of those groups. First graders, you get on this bus. Second graders, you get on that bus, and so on. Now the doing. Let's move on to the next step. The doing is the part of the policy map. These are also configured from global configuration mode, so we jump right in there, and we say policy map followed by what we want to name it. There's no match any or match all anymore. There's just the policy map. So we'll go ahead and say policy map limit HTTP. That'll be the name of my policy. And yes, it is case sensitive, so you'll have to remember if you use all uppercase or lowercase letters. From there, you can see that there's not too much that we can do. We have rename to rename it. We have no to negate something. Exit to get out. Description if we'd like to describe it. But right here, the main thing that we can do is the class command. So again, we need to get out. Let me do a show class map. We need to know what classes we have and their names and what they're doing before we can ever apply a policy to them. So jump back in, type in policy map limit HTTP, and now I'll say for the class web traffic, and then I hit enter. That's one of the keys. A lot of people just say, okay, for the class web traffic, and I start typing, right? No, we say for the class web traffic, and look at my modes here. I've got global config, policy config, sub config of class. So I'm getting deeper and deeper. We're applying a policy to a specific class of traffic. So now we're under here, and the question is, let's use the question, what do you want to do with web traffic? Do you want to use a bandwidth command and guarantee it some bandwidth? Do you want to use a police command to limit the bandwidth? And remember, again, I say it again, this is not a nugget to focus on all of the things that we can do, just the structure. So under here is where I would apply my policies. I said I had too much web traffic, I want to police it. So I can type in police, followed by how many bits per second I want to limit it to. And I'll say, well, I want to crunch that web traffic down to 500 kilobits per second, which is 500,000 bits per second. I hit enter. It's now, wow, how deep we can go. Config, policy map, class map, police. And then we would start doing the criteria specific to policing. And I'm not going to get into those criteria. I just want you to see the structure. So let me hit a Control Z, jump all the way back out, and do a show policy map. Hit enter. I now have this policy map, limit HTTP. For the class web traffic, I'm going to police down to 500 kilobits per second. Now, this policy can be applied to an interface. But before we even get to that point, I want to make sure that you fully understand what the policies are all about. One policy can limit many classes of traffic. And I'm saying limit because I'm talking about policing here. But we can limit, we can guarantee, we can do whatever we want. Let me go back and do a show class map to see all our different maps here. And get back into global config mode and get into, let's see, where am I here? There we go, my policy map, limit HTTP. It's the same policy map that I just applied that policing policy under. But that was just for one class. I now have all these other classes. Well, we'll look at FTP. So now I'll say for the class FTP traffic, case sensitive, enter, what do you want to do for FTP? Now I might say, well, on my network, this FTP traffic is very, very valuable. So I want to make sure that I guarantee it a specific amount of bandwidth. I'll say I want to guarantee it 500 kilobits per second, which essentially says no matter what, in any point of congestion, I will make sure that FTP has 500 kilobits per second of bandwidth. So now let me exit out because I want you to see this. I'll do a show policy map, hit enter, check this out. We now have this policy map that's probably not appropriately named anymore because it's doing a lot more than just limiting HTTP. It's policing the web traffic, but look right here. I have now this new class of FTP traffic, and I'm guaranteeing it 500 kilobits per second of bandwidth. This pattern would continue all the way down. I could go back in and I would go into the limit HTTP, type in class-default, and I might say for all the rest of the traffic I just want to use, we'll say random detect with fair queuing. And actually I need to turn that on first. Fair queuing. So I'm going to use fair queuing and random detection. Go back and you see what I want you to see here is that I'm building out the policy map, and now my reporting is getting a little more extensive. I just did the show policy map. Make sure you're following along with me here. Same policy map. I have the class web traffic, policing, FTP, guaranteeing bandwidth, and for everything else, that's the class default, I'm applying these methods of quality of service, fair queuing and random early detection, or RED. So we've got these different policies applied to the policy map. And I just wanted to emphasize the whole point of this configuration is that one policy map applies to many classes. I've seen many people, let me do a show class map, that will create all these class maps, and then they'll start creating a policy map for each one. They'll say, okay, for web traffic, I'll create a policy map that limits it. New one, policy map for FTP traffic guarantees it. New one, policy map for this host that guarantees them this much bandwidth, and so on. Remember, you can only apply one policy per interface per direction. So if you create many different policy maps, you'll only be able to apply one of them to the interface in each direction. So you want to create a policy map that contains what you want to do for as many classes of traffic as possible. Now we can get down to that third step, which applies the policy map. But before we do anything, let's check our traffic levels one more time. I'll type in traffic and hit enter. Yep, sure enough. Wow, it looks like we've got some more traffic since we last checked. HTTP is now, it's still significantly high, but looks like Nutella traffic, which is peer-to-peer file sharing. We've got some Lotus Notes, IPsec. So we've got a lot of variety of traffic on our network. No matter, the application is still the same. We're going to go into the interface that we would like to apply our policy to. Let's go ahead and do interface serial 0. Now that we're underneath there, I can set my policy and apply my policy map by using service policy followed by input or output. So I get to say what direction I would like to apply this in. So I would say, let's see, if I wanted to limit HTTP traffic, when I'm looking at my interface, am I getting more input traffic, meaning coming into my router, people downloading, or am I getting more output traffic going away from my router? Well, it definitely looks like I have a lot of downloaders, a lot of people bringing traffic into my router on interface serial 0. So I'm going to say input. And by the way, I really recommend looking at an output like this before you ever apply the input or output, because it's so easy to get confused with your direction. A lot of times you think serial 0, oh, well, I just want to stop output, you know, the web traffic from the web, that's output, right? No, remember, you are the router. This interface is what direction it's coming into you. So input into you would be people on the LAN downloading from the web. So I would, on my service policy, say input, and then I would put the policy name, limit HTTP. From there, I would hit enter, but I'm not going to do that because, like I said, this one is a production router. I wanted to show it to you just to get the real effect when we're looking at the different levels of traffic. But once I hit enter, you would see the service policy kick in, and I would start being able to monitor that policy map and so on. We will see lots of that configuration when we get into all of the specific tools that we can use underneath that policy map. But for now, I just wanted to show you the structure. So, let me do a show class map. First step, create the class map. This classifies your traffic into different groups, and you're going to create different classes for all the different groups. Second, create your policy map. This says what you want to do to that policy. In this case, we have one policy map for 3 classes of traffic. Remember that the classes of traffic will be numerous under a policy map. You will not create a policy map per class of traffic. You create one policy map that dictates everything that you want to do to that traffic. The final thing is go to the interface. In this case, I'll do interface Ethernet 0. It's fast Ethernet 0. And I would do a service policy command and what direction I would like to apply the policy map to, input or output, and then I would apply the name of the policy map. 3 steps, 3 phases to go through Cisco's MQC. Isn't that structure awesome? The MQC standard, 3 tiers, class map, policy map, service policy to apply it. That is Cisco's modular QoS CLI. And I wanted to have this dedicated time to talk about the MQC because we're going to use it for the rest of the quality of service series. This is how we apply all our quality of service standards in the Cisco world. So, we took a look at what the new MQC standard was all about, and that's where we laid it out on the screen, what those MQC standards look like, how we're going to set those up and apply those with the class map, policy map, and the service policy. We're applying it to an interface. From there, we kept it in the live interface, looking at nothing but configuration of class maps, which lets you separate your traffic, policy maps that says what you want to do to that separated traffic, and the service policy command that applies your policy map in the inbound or outbound direction to whatever interface you want. I hope this nugget has been informative for you, and I'd like to thank you for viewing.